Embedded systems. As its name suggests, embedded means something that is attached to another thing. An embedded system can be thought of as a computer hardware system having software embedded in it. An embedded system can be an independent system or it can be a part of a large system. An embedded system is a microcontroller or microprocessor-based system which is designed to perform a specific task. For example, a fire alarm is an embedded system. It will sense only smoke. An embedded system has three components. It has hardware. It has application software. It has real-time operating system, RTOS, that supervises the application software and provide a mechanism to let the processor run a process as per scheduling by following a plan to control the latencies. RTOS defines the way the system works. It sets the rules during the execution of application program. A small-scale embedded system may not have RTOS. So we can define an embedded system as a microcontroller-based, software-driven, reliable, real-time control system. Embedded system hardware. An embedded system uses a hardware platform to perform the operation. Hardware of the embedded system is assembled with a microprocessor, microcontroller. It has the elements such as input, output interfaces, memory, user interface and the display unit. Generally, an embedded system comprises of the following: power supply, memory, processor, timers, output circuits, serial communication ports, SASC, system application specific circuits. Embedded system software. The software of an embedded system is written to execute a particular function. It is normally written in a high-level setup and then compiled down to offer code that can be stuck within a non-volatile memory in the hardware. An embedded system software is intended to keep in view of the following three limits. Convenience of system memory. Convenience of processor speed. When the embedded system runs constantly, there is a necessity to limit power dissipation for actions like run, stop and wake up. RTOS, real-time operating system. A system which is essential to finish its task and send its service on time, then only it's said to be a real-time operating system. RTOS controls the application software and affords a device to allow the processor run. It is responsible for managing the different hardware resources of a personal computer and also host applications which run on the PC. This operating system is specially designed to run various applications with an exact timing and a huge amount of consistency. Particularly, this can be significant in measurement and industrial automation systems where delay of a program could cause a safety hazard. Basic structure of embedded systems. The basic structure of embedded systems. The following illustration shows the basic structure of an embedded system. Sensor. It measures the physical quantity and converts it to an electrical signal which can be read by an observer or by any electronic instrument like an A/D converter. AD converter. An analog to digital converter converts the analog signal sent by the sensor into a digital signal. Processor and ASICs. Processors process the data to measure the output and store it to the memory. DA converter. A digital to analog converter converts the digital data fed by the processor to analog data. Actuator. An actuator compares the output given by the DA converter to the actual, expected, output stored in it and stores the approved output. Characteristics of an embedded system. Generally, an embedded system executes a particular operation and does the similar continually. For instance, a pager is constantly functioning as a pager. All the computing systems have limitations on design metrics, but those can be especially tight. Design metric is a measure of an execution features like size, power, cost and also performance. Several embedded systems should constantly react to changes in the system and also calculate particular results in real time without any delay. For instance, A car cruise controller, it continuously displays and responds to speed and brake sensors. It must calculate acceleration, decelerations frequently in a limited time. A delayed computation can consequence an letdown to control the car. It must perform fast enough and consume less power to increase battery life. It must require a memory, as its software generally inserts in ROM. It does not require any secondary memories in the PC. It must need connected peripherals to attach input and output devices. An embedded system is inbuilt with hardware and software, where the hardware is used for security and performance and software is used for more flexibility and features. Applications of embedded systems. The applications of an embedded system basics include smart cards, computer networking, satellites, telecommunications, digital consumer electronics, missiles, etc. Embedded systems in automobiles include motor control, cruise control, body safety, engine safety, robotics and in-assembly line, car multimedia, car entertainment, e-com access, mobiles etc. Embedded systems in telecommunications include networking, mobile computing, and wireless communications, etc. Embedded systems in smart cards include banking, telephone and security systems. Embedded systems in satellites and missiles include defense, communication, and aerospace. Embedded systems in computer networking and peripherals include image processing, networking systems, printers, network cards, monitors and displays. Embedded systems in digital consumer electronics include set-top boxes, DVDs, high-definition TVs and digital cameras. Bibliography: elprocus.com, techart.com, tutorialspoint.com. Thank you for watching this presentation.